Guys, I'm Sandesh. I'm the CEO of iceDQ. For people who wonder what iceDQ stands for, is Integrated Check Engine for Data Quality. And today, I'm going to talk about, where's the first slide? Data quality and data reliability. So, there's one important piece of information I want to give you before I go through the slide. I had a conversation with many people in the forum over here, and one of the points I'm telling them is my background is mechanical engineering. And this is very relevant to this presentation. The reason is, when we look at what we do with our data, how we process it and how we generate data or store data, to me, it seems no different than a factory, how we run a factory. And what I try to do with this presentation is to try to bring in the manufacturing concept to the data world, and I call it as a data factory. So everybody's talking about AI. I'm not going to bore you with all those things, but AI sits on top of data. The first thing that comes is data. And if something is wrong over there, your AI is going to behave in a different way that you don't want. And if you look at these slides over here, so these models are failing because there was something wrong with the data. And then the question is, we are talking about data quality since maybe 20 years, 25 years, 30 years, right? Why do we still have the problem? Now we have started talking with AI because it's in fashion, but the underlying problem with the data is still there. So if you look at all these failures and look at some of the stats generated by research institutes and all that, it says 80% of the AI projects are likely to fail. 30% of AI projects will be abandoned by the end of 2025. So whatever you start, 30% of the projects will be let go of. A conventional IT project has a high failure rate, but AI projects has a 2x failure. Now think about it, right? So the question again comes back to us is, why are these failing? And there are many reasons. Okay? And one of the fundamental reasons within that is the data quality that you are getting. And the way we understand data quality is also a problem, and then we'll go through a few slides, and then once you see that, you'll see, hey, why didn't I think about it? Okay, so let's go to the next one. Everybody, is there anybody here who has no idea about these measures? What we measure? Accuracy, completeness, uniqueness, consistency, timeliness, validity, and there are a few more. Everybody knows about this, right? Everybody is implementing it. So the point is, if you are measuring everything, you are counting everything, you are taking care of data quality, so then why are the projects failing? Right? It should not happen. If you look at this, I am doing the job, I have these nice dashboards in front of me. As if you are engineering leads or data management heads, you have all these things. So why are they failing? There could be many answers, but the one thing that I pointed out from my experience, and I'm going to take that experience, share that experience with you. Read that line. Say, read my lips. Because by the time you are measuring, it's too little, too late. Think for a moment. What you are measuring is the output that has generated by your system. And if I tell you that, okay, there is a problem with your data, here's an example. The TSB bank, they came to know that data was one of the major issues why their project failed. And the reason was, of course, they didn't do data testing. That was the main reason. And the result was data quality issues, and they were fined by like 48 million pounds, and even the CIO of the project was personally fined, it's not there, but about 80,000 pounds or something. They lost, officially, they lost around $330 million. But if you look at the overall picture, they lost around $1 billion or so in that project. You can Google it, you'll find it when you get a chance. Now you're saying, oh, Sandesh, you said you're a mechanical engineer. Why are you showing me this? Right? So look at this. How many have you heard about this thing? Right? See, the Titan, the submarine, imploded 13,000 under sea, under the water. Right? So look at this. The passenger and needed to be certified. Look at the last words. The system was not certified before it went and they started using it. So what it has to do with data quality? Think about this. Look at your project, look at your data. What are you doing? You are measuring at the point of failure when the system has already failed. So now, if you are in that Titan ship and I tell you, oh, the system is faulty and it's breaking, what is of the use to it to me? So at the most, you can try to manage the situation, right? The term everybody has, "Arey, manage kar lena yaar," right? So when you do data quality with that mindset, that is what is going to happen. Another example, if you look at the Boeing, this lost a door at 16,000 feet in the air. I didn't make this up. So if you look at the guy on the bottom, so there is a YouTube interview of this guy. His name is Sam, and he's a quality engineer at Boeing. He said, and this is where I bring the data reliability and I'll explain that we didn't follow the quality standards, the data reliability engineering ideas that we are supposed to do. We didn't do that. That's why it failed. So there are two angles to this. One, it's too late because you are flying 16,000 feet and tell you, hey, you know, I got this nice dashboard, and you see my quality has this score, it's 0. It's too late. The other thing is, when that happens at the end of the production line, again, it is too little because you are left only to manage the system and not actually do anything about it. Okay? So let this sink in, because many times we think, oh, we are the IT people, we are the data people, we are the experts, and we know all the solutions. But sometimes you have to look at the parallel industry. Maybe it's manufacturing, maybe it's flying, maybe it's shipbuilding, I don't know. You have to look at other industries which are much older. IT, data engineering, this all came now, but manufacturing and all that is going since long time. So we always need to learn lessons from other organizations, which they themselves forget, by the way. So then, having these conversations, what happened? Everybody will say, okay, then what is the difference between data quality and you're talking about data reliability? So you will get the classic definition of data quality, but I said, no, I'm not going to go at the definition of data quality. Let me look what is quality. In a way, you know, expected versus actual and all that, but it is whatever you calculated, quality is an instance in time. Okay? And I say, what does it mean? And I will give an example again from the parallel industry. And this is very important. So then, if quality is an instance in time, what is data reliability? Data reliability is delivery of quality consistently over time. Seems like, okay, so what's the big deal here? The big deal is, if you take again an example from the parallel industry, so if you're making a knife and you cut apples with it, so you take the knife, you cut the apple, beautiful. I keep the knife on the apple and you have 2 pieces, right? Now, I go to the second apple, I put the knife and it stops cutting or it breaks. So there is a difference between having a quality and reliable, because at that point, if it cuts 10 apples and after that it stops cutting apples, or if you go in a battlefield with a sword and you do a great job in the first strike and after the second strike your sword breaks into pieces, so that is not a reliable sword. It might be a good quality sword, but it's not a reliable. So now think about this: is what do you really want? You want a good quality knife or a a reliable knife? Think about this again. If you are going to a battlefield, do you want a sword that is good quality or you want a sword that is reliable? Okay. Now, then you say, okay, so then Sandesh, what you're telling me is I need a reliable, and reliable has only one dimension, that is consistent. No, that is not true. What reliability means is it is an additional dimension on top of quality. Whatever quality you define, you have to have that reliably delivered over a period of time. Okay? So think of data reliability as quality plus time. Then, okay, so you told us what is the difference. So what do I do about it? Reliable data quality delivery is not an accident. A bad quality is an accident, right? So you don't design accidents. If I have a car accident, it's something I did wrong, right? But if I have a good training, good practices, and all the right things in place, then I can have a data reliable. I will have reliability over time. So if you think about this, and again, we have to go to the you can go to manufacturing, or you can go to the Bhagavad Gita, where it says, follow good processes. The outcome will be dependent on the process that you follow. Don't worry about the outcome, because your process is good, your outcome will be good. Now, if you take that back to data reliability engineering, if you get a chance later on, you can look at reliability engineering and how they do it. You can look at, there are 3 factors that you put in place: people, process, and tools. The important point here is what I'm doing here is I'm trying to change the thought process of people. You have to change, the management has to bring these ideas down to the developer, to the testers, to the data pipeline developers, that, hey, we need to worry about this thing. What are the things that I need to train you? What I need to do with you? Then implement process, and we'll talk about the process. The processes are, what processes do I put in that I will deliver quality data or reliable data, right? Quality data over time, that is reliable data. And then I need to empower the person and the process with proper tools. What tools do they have, right? That will give you the results that you're looking for. So, again, as I said in the beginning, being a background with mechanical engineering, I again look at this thing, what am I doing? So essentially, if you consider data pipeline engineering and all those things that we do in the as a data factory, it has 3 distinct phases. The phase 1, when you buy the machines, the process and tools, and assemble it, but you are not running it. So when you are assembling your system, building your system, the question is, what do you do with it? So if I am asked to set up a factory, actual factory that manufactures cars or something, I will check each and every part. I will check the machines are proper, the toolings are proper, they are within the specifications, the power is, has a correct power factor, and there are a lot of things. And how do I know that everything is in place? Is because I am testing it. So the question that comes to your data factory and my data factory is, when I'm building the system, what do I have in place to test it properly? Am I even testing it properly? Okay, so that's the first part. Now, the factory is assembled, you tested all the machine toolings, everything is in place. All the ETL process and the orchestration and scheduling, everything is in place, everything is proper. Then the second question is, I now to click on the green button that starts the factory or the red button that starts the factory. And then there are 2 parts to it. The input data determines there are 2 factors that determine the quality of the data that it generates. That is the input data. So what do you have in place to check the data that is coming into the factory, right? So you get files from vendors, you get data from some other systems. Do you check them? Do you monitor them before you start processing them? If not, why not, right? Because if, regardless of how good your factory is, if I give you bad products, raw material, you're going to produce bad product. So that is one thing. The second thing is you need to monitor the processes itself. Because if you don't monitor the processes, so sometimes what can happen is accidentally you can kick out the same process twice. It is possible that the process runs, and loads nothing. There are a lot of things that can happen which are silent failures, which a controlling system or a system cannot capture. So what do you have in place to monitor the raw data that is coming in, the files coming in, and what do you have in place to monitor the processes that are running, the orchestration that is running, right? How do you know it's actually done the job that is supposed to do? So that is the second part. So now you have made sure the assembly of the factory is good, data factory is good, your raw data is good, your machine is running correctly. There is a third part where the product is coming out on the right-hand side. Now this is again very important. In a real factory, you know what they do? They take the products out and they do sampling of the data. So that's where observability and things like come into picture, where you see normal weight of the product is 40 kg, this is like 10 kg, so something is wrong, maybe the box is empty, maybe the dimensions are not correct. So you need to do some kind of the final product that you now think about. The data quality that you are thinking, or I was thinking earlier, comes in the phase 3, not in the first 1 and 2. It's a big difference. It's just one slide, but now you see where I personally see, and you don't have to agree with me, but the way I see this, what we used to classically think about data quality comes in the step 3, not in step 1 and 2. Right? So let's move. Again, you said, okay, there are 3 places. I'm doing only in the last place. So what is the big deal in this? Let's look at the big deal. Before that, if you look at data testing in the first step that we are talking about to achieve reliable data, what are the things that you're doing? You are doing the development of the pipelines. Do you have the audit requirements? Do you know how to test the pipelines? Do you have anything in place for unit testing? If you are testing the data pipeline, what do you have to test? Do the QA testing, integration testing, UAT testing, regression testing, what do you have in place? Think about it. If you are deploying the CI/CD pipeline, how are you certifying the pipeline? You take out the ETL code from the gate and deploy it, and you do all those things. How are you doing it? What do you have in place? What infrastructure? What toolings? What actions are you taking? There is, everybody probably has heard the word observability, but there is something deeper than that. There's something called as white box monitoring. And I will explain that this is part of the development that you have to take care of. Is when you buy a car, you already get the speed meter, and you get the oil gauge and the pressure gauge and fuel gauge built into the system. So the system becomes observable. So one of the things you need to do while you are doing data testing, and part of the test has to be deployed as you deploy the ETL pipeline, data pipelines, you need to also embed the white box monitors into the system. So this is one part that you need to do. So of course, these are the things you need to do. You will need tools for this. So we talk about processes, but you also need people. Are your business users involved in there and saying, how do I know if my data is correct or not? How do I know how to test this process? Who has given you the audit requirement? Who has given you the testing requirement? Who has given you, who is going to automate this? Are your testing QA team even trained in data testing? Do they know how to do data testing? Do they know how to do data pipeline testing? Do they know how to check your JSON files that are coming in or some other files that are coming in? So even if you decide to do data testing, there are people, process, and tools. You need some kind of tools, you need the processes, and you need the people, relevant people involved in this. Now, you don't have to answer it to me, but think about this. What is your organization doing from this perspective? Of this, how many things are you doing? From people, process, and tools, how many things are you doing? The data monitoring. As I said, when you receive the files or you receive the data, are you doing the checking of the data? If you're receiving the files, are you checking the files? How many, think about this, again I'm not going to ask you, we'll have a Q&A at the end, but how many times you accidentally receive the same file that you received yesterday? How many times it has happened that while running the system, while running your data factory, you process the files, but it didn't process anything because the file was empty? How many times it has happened the file came with the numbers don't match, the location of the column is changed? It happened to me so many times. Then, because fundamentally the data is moving from one place to another, if I came from New York and I landed here, the way to audit this, the way to check is to reconcile if I should exit there and should enter there. So in your data pipeline, how are you reconciling whatever you gave is loaded correctly or not, or transformed correctly or not? Do you have business checks in place? For example, you cannot ship a product without orders. For all the shipments, do you have orders in place? Then, have you embedded these checks as part of your data pipeline? Because if you are not embedded the checks in your data pipeline, will it stop? Remember, one of the things I said, data reliability is different than data quality. Data quality is at the end of the thing. But if my in-process checks fail, can you stop? Can your system stop the data pipeline right there? Or it will continue? Then, so you need checks and controls. They're called ABCs, checks and controls, audit, checks and controls, balance and controls. So do you have in this place? And then are the ops people being notified? So the persona that was involved earlier is mostly QA people and data engineers. Here is mostly ops people and data engineers or business users. Going to the third section of this. So you have now prevented as many defects as possible. Now the third part of this is, okay, I follow, the Lord Krishna's following, and I check my process, everything. That doesn't guarantee outcome. That only guarantees 99.99%. So there is still something you might have missed. So this is where the data quality, data observability, all those things come into picture, where you have pattern detection, or you can have all kind of notification, ticketing, analysis, whatever you want to have. But see, I spent 80% of my conversation here on the testing side and the monitoring side, and hardly anything on this side. Because if I have done my best, here there should be least amount of problem. It doesn't mean you don't do it, but you have to do in such a way that this requires least amount of your attention, least amount of effort, so that you can deliver not good quality, but reliable data. So basically again, I've just summarized this. If you do this thing properly, 80% of these defects, if your processes are designed properly, they are tested properly, the business rules have been taken care of, you should be able to prevent your data quality issues right there, right? The 15% comes from operational issues. When you are running your process, you have source data coming in, flat files coming in, the format checks and all those things, checking the process doesn't run accidentally twice or things like that. That will take care of about 15% of it. And see, it could be anywhere between 5 to 1% that is checking the final product. The data quality approach, yes, follow that, but at the end. But you see now, if you go with the data reliability mindset, that is the least amount of your problem. Again, I'm now saying you don't do it, but if you take care of things properly, that should be a least problem. We have 5 minutes left, right on the time.
Yes, we do. We have 5 minutes.
Yeah. So if any, we'll have a Q&A, but my thing is take one thing from this. There's only one thing that you need to take away from this, meeting over here. Will you go to a fight with a good quality sword or weapon or a reliable weapon? And if your answer is, hey, I will go with a reliable weapon, then why not follow the same philosophy in our job? Because what we are going and fighting against is the poor quality, right? The mediocrity. We are fighting, we are going to the corporate or enterprise or your own business with the same thing. Why can't I do the same thing for what I want for myself in a battlefield? I want the same thing over here. So if time permits, we'll have Q&A, but the point again is shift your thinking. I don't know how much you will change in the organization, but if your thought process changes, these changes will be reflected in the organization as well. With this, I'll open up for any questions or anything you have.